And now, the Less Wrong posts.
Yeah, the first one is Expecting Beauty.
Gosh, how long has it been since we did Less Wrong posts? Did we do them last episode?
It's been well past when we typically do them. I think we've missed at least 2 episodes. Then we took off winter holiday. It's been a month or 2.
It's been long enough that I think I should very quickly give the context for this. The previous episodes were discussing the mathematical systems and the underlying beauty that emerges out of them, and how you can take some time and just dive into it and kind of be blown away by the elegance and the beauty of mathematics. So these posts continue on from that.
What I like about these is that it's like, this was what I loved about Richard Dawkins' Unweaving the Rainbow. Here's a guy who's just crazy about the poetry and not magic explicitly, right? Explicitly not magic, but the joy, the thrill of nature and science and understanding, right? This is that, but for numbers.
Yes.
And it's just great. Whatever anyone's excited about something and they're talking about it always makes me happy. So like I don't necessarily have the same math boner that he has, but I can appreciate that he's stoked on it, right?
Totally. The first post is about expecting beauty. He gives a sequence of numbers and says, suppose that you're handed the sequence. Clearly, it doesn't have the same neat order that we saw in the squares, so you might try to impose some order. And he goes around giving some hypotheses about how someone might try to impose order on these things, and how it's kind of clunky and doesn't work very well because the numbers don't seem to have a pattern that is easily recognizable. And therefore, the people, the onlookers, the naysayers out there saying nay, will say things like, this is what happens when you always try to find beauty and elegance everywhere. Real life is much more complicated and messy than all that, you math nerds. But Eliezer goes on to, find a way eventually to get beauty out of it. And obviously, he's working with a sequence that he knew was going to lead to beauty. So it's a slightly contrived example, but it's an example of a point. And he says, look, you keep working at it, you keep diving down, you can find beauty and elegance after all. The problem was that the first person trying to impose beauty and elegance and order on this thing grasped too quickly at order and demanded closure right now and forced a pattern. And someone who does that might never find the stable level of the actual emergent, elegant pattern to it. If you try to tweak the first differences you find to make them more even and fit your own conception of aesthetics before you found the math's own rhythm, he says, then the second and third differences will come out wrong. The moral is to reduce at the right time and wait for an opening before you slice, not to prematurely terminate the search for beauty. So as long as you can refuse to see beauty that isn't there, you've already taken the needful precaution if it all turns out ugly.
I like it. I think the only quibble I could imagine with that summary would be it's at the emergent beauty. And I think that emergent is one of those
Oh, yeah.
So I'd also say that it's not necessarily, it's not even in the context where people like using the word emergent beauty. It's underlying beauty, right? So the beauty of, I'm glad he chose something simple like squares to start, because, some of his math examples, the inferential distance is a little high for me and doesn't make good audio.
Oh God, wait till we get to the quantum mechanics sequences.
I wonder what we'll do with those. We'll figure it out. But they're
going to have to be much more reacts rather than talking about exactly what's happening in them.
Right. But it is kind of cool because, you can picture squares. And once you kind of get the picture where it's oh yeah, 5 on one side, 5 on another, 25, 6, 6, 36. Once you get the pattern, you can visualize it. Mm-hmm. And so it is kind of just this underlying principle of it, right? Mm-hmm. I'm sure there's emergent beauty in math too that I just am not equipped to pontificate or understand about. So,
one of the things I really like about this post is, it's not just saying the naysayers are a bunch of jerks and don't accept their needling too easily, but it also is don't jump too quickly at this stuff. Don't be the overeager person. The most zealous person is always the new convert, right? And you don't want to be that extremely zealous new convert kind of person. It's important to refuse to see beauty that isn't there. Just because you want there to be beauty, don't try to impose it. I think it's a lot like, sexual relations in that way. If you try to force it, it's never going to work. You got to wait until it emerges, and maybe it won't at all, but maybe then it will. And math is kind of the same way. Doing math is like chatting up and kissing a beautiful woman. You don't force things.
Well, and you're not going to find whatever the best parts without some practice.
That
Like
too.
if your first time with a partner is like the best ever, then I guess you guys won the lottery. But usually it's like, all right, now we know each other's rhythm, you know? I was thinking
So
like,
the first derivative didn't work.
you know, I guess I'm hung up on unweaving the rainbow, but the idea that God made rainbows and aren't they pretty? That's one way to appreciate a rainbow. If you understand how rainbows actually work, you might say, well, look, you ruined my version of how pretty it was. And it's like, no, man, I gave you a really cool version of it. And isn't that beautiful in its own unique way, or like in its own new way? Right now, I look at the window, I can see a sunset. God made sunsets. Isn't that nice? And it's like, well, that's one answer. But understanding the reality of it has its own beauty to it. I guess what I'm trying to say is like shoving on like your first example of stuff. I think it's a failure pattern that applies to other kinds of things.
Absolutely. And that actually segues very nicely into the next post.
Almost like I did it on purpose.
The next post is reality ugly? He asks, is a real world uglier than mechanics?
Mathematics.
Sorry, what did I say?
Mechanics.
Mechanics. Well, mathematics, yes. And he says, yes, strange that people ask this. Beneath the complex forms and shapes of the surface world, there is a simple level, an exact and stable level whose laws we name physics. And he calls this the great surprise, which I think is a great way to put it, because you wouldn't have just guessed that naively if you didn't know any of this and looked at the world. He said, once upon a time, people went in search of underlying beauty with no guarantee of finding it. And once upon a time, they found it. And now it's a known thing and taken for granted. But that's kind of fucking crazy, right?
It is. I mean, I always like learning about, you know, how did the ones that helped figure out with actually pretty solid accuracy the rough circumference of the Earth. And how did they do that without being able to travel farther than you can walk? And it's like, well, they could do a solstice at one city, put a stick up and get a perfect non-shadow. They could do a solstice several miles to the south the next year, stand a stick up, and then measure how long the shadow is and do some trigonometry, right? And so it's crazy seeing how they get there. You know, again, that's doable with 3,300-year-old math, right? The only quibble I would draw with Eliezer's thing here is, you know, the simple, exact, and stable level we call physics. And it's like, all right, well, you say that, but then I stopped reading popular science books once they always started talking about the wave function.
Right.
If you can explain to me how that's stable and simple, then I'll quit challenging you on this. But I think physics is like the answer to how stuff works. Yeah. And you can get to a good enough explanation without getting to the bottom level. So he says, beneath the complex forms and shapes of the surface world, why does blowing on a spoonful of hot soup cool it down? The answer is simple and cool to explain and cool to understand. Would
you like to explain it to us?
I don't want to ramble on too long, but the short version is It's like heat is the measure of how fast the molecules are going in whatever it is you're measuring in, or heat energy rather, and temperature is the average that, you know, so when you've got a liquid with fast molecules in it, some of them escape the surface. It tends to be the fast ones because they've got the most escape velocity. That's why you're seeing steam. Blowing on it creates less pressure behind. It's a lower pressure zone for the molecules to escape into.
So it makes it easier for them to escape.
Right. And since on average the faster ones escape, the temperature drops.
Cool.
But if you're going to ask me, all right, well, explain that, but talk about quarks instead of atoms, I'd be like, no.
Right. Yeah. I think what he means by simple and stable level is that it can be summarized in a number of equations, which is kind of mind-boggling.
Yes.
When you look at just how complex the entire universe that grows up out of them is.
Agreed. I'm totally on board. I think it's because you mentioned quantum physics earlier that I was like, well, hold up a minute.
It's not that easy.
Right.
You need at least 1 degree to understand this shit.
Yes, and I only have a theoretical degree in physics, so...
Right. So he does ask that sort of thing, like, why is it that if there is these simple, exact, and stable level where you can sum up everything that the universe does in a few equations, why is it that you can't predict exactly where the tiger is and what bush he's going to jump out of, and so forth? He covers 3 big sources of uncertainty in answering this question. The first is that you can be governed by stable fundamental rules without knowing them. We do not yet have a theory of everything. So first, we just don't know all the rules as they are even at this moment. He also says that even when you know all the relevant laws of physics, you may not have enough computing power to extrapolate them, which I think is pretty much what you were saying with the blowing on the spoon. How do I translate to quarks? Just no.
And I think this is probably from another post, but like there's also like a useful level to abstract something to.
Yes.
You know, like if you're modeling I think he probably used the example because it sounds like something he would have come up with. The example of the Wright brothers testing wind tunnels, even if they were thinking in terms of atoms, let's assume that that was on their list of options. It would have been ridiculous to think of the plane of a wing in terms of quarks, right? Let's think about it in terms of like a solid, like an actually solid, flat-ish, disk-ish thing, and figure out how air moves over it best.
Right. Like we're not even thinking in terms of molecules at this point. It's just a solid object that we're working with, and that works.
Right.
You'd never get anywhere if you were trying to do quark simulations.
I think I mentioned this years ago on the show, but do you remember that episode of Rick and Morty where they're all in a simulation for some reason?
Uh-huh.
And Rick is in the garage like, ripping apart a rat, and he's like, this is just bad craftsmanship or something. I'm assuming it's because the rat didn't look like a real rat on the inside.
Okay.
Like it was some cheap version of, like when you're playing a video game and you can move the camera, you get the character close to a wall and the camera moves inside their head. And you see like this horrifying back of eyes and teeth, and that's it.
Right.
Because it would be such a waste of computing power to simulate a circulatory system inside the, every NPC, right?
Exactly.
So, anyway, a level of abstraction that's appropriate.
At this point, I want to quickly mention I was just introduced to a show. You saw Parks and Rec. Who was the guy that plays Ron Swanson?
Nick Offerman.
Nick Offerman, that's right, with the amazing voice and these piercing eyes, right?
Yeah.
He plays one of the main characters in this show on Apple Plus called Devs. And I've only seen the first 2 episodes, so I don't know if I can actually recommend this. From the first 2 episodes, it's really fucking compelling, though. It's done by the same guy who did Ex Machina and Annihilation. It's like good, high-concept sci-fi, kind of mind-bendy. Based on how those other 2 movies go, I assume that I'm going to be slightly disappointed by the ending, but the trip is going to be absolutely worth it. From what I gather in the first 2 episodes, it is about a tech company in the near future that creates a computer powerful enough to literally predict things down to the quark level, and so they can literally predict everything forever.
Neat.
As far as I can tell, yeah, and what the implications of that are. So far, I'm really loving it, but let's see if I continue to love it. I don't know. I wanted to tie in, we do not have enough computing power to extrapolate them, but what if we do? Here's an awesome sci-fi concept.
And it looks like it's on Amazon Prime and on Hulu if you already have a subscription. Well, Google it. Find out where you can watch it.
Okay.
All right. Anyway, sounds like fun.
All right, and the third area of uncertainty that he spoke of is, he says, to figure out what the night sky should look like, it's not enough to know the laws of physics. It's not even enough to have the logical omniscience over their consequences. You have to know where in the universe you are. And that might be a thing that you don't know, metaphorically speaking, with whatever it is you're trying to figure out. So 3 big sources of uncertainty, which make predicting absolutely everything very difficult, possibly impossible.
When he's saying uncertainty, he means the inability to perfectly predict the future?
I think so, yes.
Okay.
Yeah, like you can perfectly predict what the next number in that sequence is going to be, but you can't perfectly predict whether you're going to run into a tiger tomorrow.
Right.
He goes on to say that ignorance of fundamental laws does not tell you that a messy-looking pattern really is messy. It might just be that you haven't figured out the order yet, that's right. That's why we were covering those 3 sources of uncertainty. That reality might look messy to you, but not actually be messy at the most fundamental level. But he does give the caveat that when it comes to messy gene expression networks, we've already found the hidden beauty, the stable level of underlying physics. But because we've already found the master order, we can guess that we won't find any additional secret patterns that will make biology as easy as a sequence of cubes. Knowing the rules of the game, we know that the game is hard. The elegance, the rules that govern physics, is too far down to help us overcome our indexical and logical uncertainty. Similarly to how, knowing the basic few equations of the laws of physics is not going to help you describe blowing on that particular spoon.
I mean, it depends on how deep of a problem you're trying to solve. Like, the fact that they mentioned squares in biology is fun because, like Punnett squares, you've got, say, a trait, blue eyes. And if you know it's recessive and you do the parents and then the possible permutations of that, if they each, say, have the recessive gene, and you can figure out the probability that the offspring will have it. It turns out that if it's blue eyes and if both your parents have brown eyes, but the recessive are blue, I think your odds are 25%. It's not exactly 25 because it's not quite that neat, but it's close enough for a lot of stuff. Like the Mendelian pattern of inheritance.
That's the word I was thinking of.
Yeah. So, there is some cool, simple stuff. But if you want to know, like, how tall is my baby going to be? Like, that's going to be harder to figure out, even if you have their full genome and can understand it, actually.
Right, because a lot of things impact that after birth as well, or even, after conception, I guess.
Yeah. And after birth.
And after both. Yeah.
Somehow I have an identical twin, and I think like an inch taller than he is.
That's nuts.
I mean, and it's a reasonable fraction of our total height, because it's not like we're 6'7".
I mean, an inch is a lot for anyone, no matter how tall you are.
Phrasing.
Oh,
but I bring that up because even with identical genomes, my brother and I have different heights.
Oh, did you fill out the not Slate Star Codex, Astro Codex 10 survey this year?
No. I need to get like on some email list for these things.
I was going through the results, and there was I believe 76 identical twins. And I was like, hey, I know 1/76th of all the identical twins that read ACX.
Alas.
But apparently I do not.
Next year. Yeah. Anyway, height is more complicated than eye color.
Yeah. Finally, he says, again, but bring us back to whether things are beautiful or messy, but uncertainty exists in the map, not the territory. If we are ignorant of a phenomenon, that is a fact about our state of mind, not a fact about the phenomenon itself.
That's the bumper sticker.
Exactly. Yeah, that's a good one. I was just wondering, so in the end, is reality ugly, in quotes, for this definition of ugly?
Define ugly. Give 3 examples. Give 1 example.
Okay. I was meaning the beauty of, the mathematical type of beauty.
I mean...
Of order and patterns.
But I think that, to the proper level of abstraction, it works for the caveman who can't count. They might not know math, but it's like they can anticipate where the stars will be, because they've got nothing else to do. They spend all night looking up, right? I think that there's a beauty in that. I'm bad at these sorts of questions.
I guess it's a 2-part question. The first part being, do you find beauty in relatively simple, stable patterns that are easy to state explicitly? And do you believe that reality looks like that? I guess if the answer to both of those is yes, then reality is not ugly.
I think reality looks enough like that. It does seem to say that the more your understanding goes up, the prettier or uglier it can get. But again, I think I'm perfectly happy with my understanding of why a plane wing creates upward draft without having to reduce it all the way down to quantum wave function. So I think that at the right levels, things are totally fine. Mm-hmm. And somebody looks at the wave function and, wants to get it tattooed on them because they think it's beautiful. For me, it just makes my nose start bleeding when I look at it. So it depends.
I think you can have 2 different kinds of beauty, because I think the beauty of light refracting inside of a crystal and how orderly and easy to define that sort of thing is, that the patterns from that is beautiful in one way, but it's beautiful in a very different way from a touch and a kiss is. And I think if you can appreciate both types of beauty without thinking that they're in conflict, then reality can certainly be beautiful. I think it's only if you think that one detracts from the other in either direction, then this might be an issue with reality being ugly or not.
Yeah. I don't want to say it's a wrong question, because I know you're stating it rhetorically, but if someone tried to push me for a real answer, that's what I would say.
Okay.
What could you possibly mean by that? Hitler existed. That's terrible. That was ugly, right?
Right.
Does that mean that reality is overall ugly? What the hell does that mean?
Yeah.
Right now, puppies exist.
Yeah.
There's a small child getting their first puppy kiss right now somewhere on Earth, and that's the most beautiful thing in the history of the planet, right? Mm-hmm. But does that mean reality is not ugly? I don't know. That's a weird question.
Is the fact that could, in theory, be captured in a wave function and described mathematically if you knew things precisely enough, is that beautiful or ugly?
I think it'd be a very long equation.
Sure. Yeah.
That's all I can say.
Okay.
If I was really, really good at math, I'd probably think it's awesome.
All right.
So, all right. On the last philosophical note, do you ever imagine that it could be possible with? I mean, I'm going to have to constrain it some way. It's some sort of a brain that your brain could theoretically evolve into while still being vaguely called human, to where you could look at a giant equation and be like, that's a puppy kissing somebody, and it's beautiful.
Not and be human, no.
No, I don't think so either. I remember hearing somewhere that allegedly some music school,
I heard about this.
Yeah, they would just like read the composed music pieces by the graduates, and like they would just look at it.
Yeah, and they could hear it because they know what notes correspond to what sounds and all that. I can totally see that.
Well, that's the thing.
That's
though.
like-
Depending on how complicated your thing is, could you actually? Maybe they must be able to, or they at least say they can. Maybe they look at how pretty it looks, and they just determine from that, right?
I absolutely believe that you could read sheet music and hear the music in your head if you have the skill to do it. Like, we can read words and see beautiful images in our head, right?
What if it was an orchestra, like that you're composing for? Like it's half a dozen different musical groups.
Yeah, I don't know. Maybe if you have the ability to read all 6 tracks or whatever they're called and keep them all in your head at the same time, it might be possible. You'd probably have to be a genius.
Any music savants out there want to let us know? I'd be really, really curious at the answer. Anyway, what are we talking about next time?
Next time, we are reading the LessWrong Post's Beautiful Probability and Trust in Math.